So we have, including this one, we have two more lectures, and that will be the end of the instruction. So what I'm going to do is today I'm going to finish the standard template library, and on Wednesday I will dedicate it to help you to review the findings. Okay, so just let you know. That's, and of course, the office hour will host it as usual until the final. Yeah. Sorry, can you speak louder? No, you cannot work with others during the final. You can work with other people to prepare it for that. But during the final, you're actually going to do that yourself. Yes.
Is the final
Open book, open ChatGPT, just like a midterm. Yes, within the test, you can open internet, you can open, but you are not supposed to communicate with each other. So you during the test, yes. Yeah, in the back and then.
Are we going to get the questions in advance like the midterm?
No, but you will get a lot of hints on Wednesday. So a lot of this final exam is that you're going to see what is a piece of code. I'm going to ask question, and I will on Wednesday give you a lot of hints about what type of question you will be seeing. I would say that if you have done the homework, you understand the source code I hand out during the lecture. I hand out a lot of code. You shouldn't have any problem to do beautifully for the final. Forgot what I want to say. Yeah, I should leave it as that. Yeah, you have a question. There are some, a small amount of question. Looks like is a multiple choice. Like, is this a is it correct code, and why is not? Of course, I will ask you to explain a little bit about why you choose that answer. We'll go over that on Wednesday about the final. I hope to entertain more questions like this. Okay, any short question? Yes, please. 2 hours, just a regular final exam. 2 hours. Yeah, in the back. I will say the Wednesday lecture will be a good study guide. Yeah. All right. So, okay. All right. So what I'm going to do today, last Friday, we have seen the source code of OpenAI's.hpp. And from there, we did the exercise about, what kind of template they're using. So essentially, they're using two major templates. One is STD map, one is STD pair. I mean, there is another very well-known and very popular template is STD vector. I'm not going to cover STD vector because it's really similar to array. So I'd like to spend today to talk about STD pair and STD map and how these two together, they actually do a lot of interesting things. So in last Friday, we looked at OpenAI code. They're actually using this too. But today, you're looking at, say, the library you use, JSON CPP. They're also majorly is using the STD map. So we're going to go through the simple example of STD pair and then STD map, and then we'll go into a more complicated real-world usage of this map or this template library. My hope or my objective is that after you going through this lecture together with the previous lecture on this subject, I hope that you now will be very comfortable to actually develop a library just like JSON CPP or just like OpenAI yourself with the knowledge. Of course, you will have some corner cases which you don't know. in between Google and your reading about other people's source code, I think that is a beautiful learning experience for you to actually move on. Okay, so let's actually, I already include all the code in the GitHub program I shared about half an hour ago. You can actually download. Here is the code. Let me actually bring to my, yeah, here is this the code? Yes, it is. All right, this is the directory contain a bunch of things and that we're going through today. Okay, this is directory. So first, I'm actually going to talk about the first STD, which is STD pair, which is talk about how do you actually define a couple of objects or data that actually might belong to different types. So you can see that it's a very commonly used scenario. So I have a program called pair test. Is you have to include the utility to be able to use pair. So you can see that pair is a template. Remember, how do we know it's a template? It's a standard template. Is you must start with std : something, and then you actually see the template introducer, which is a smaller sign and bigger than, smaller than and bigger than, in between. So essentially, a pair take a two parameter because it's a pair. In this case, I actually put two objects together as a couple. And this object, the first one is an integer. The second one is a character. So you can see that I actually define STD pair in character, and then I define. So by the way, this part is the, hold on 1 second. Yeah, I think that's fine. So this part declare the type about the instantiation of that template using this two argument, which is the type integer and character. You can use anything you want over there. And then I declare a variable called pair1. Okay, this is just a variable under that instantiation of the pair template. And then this is interesting. The way to access pair, this is what I want you to learn, is first and the second. So essentially, if you look at the way they define pair is that a pair is one, then I want to know who's the first, who's the second. So that's why it's actually this parameter first, second. So in the code, by the way, in the code, somebody else code, obviously, whenever you see first and second in C++, that usually indicate they're using pair, or they're using something which is derived from pair. Okay, so that's first and second is always a pair. All right, so you can actually say pair1 dot first is supposed to be the integer, and pair1 dot second is supposed to be a character in this case. All right, so that's why you can actually write this program. Very simple. So pair is actually fairly straightforward to use. You just declare something, you use it. Okay, any question? Okay. All right, that went well. So let's look at the second one, which is the map. So let's take a look at the map. So a map is essentially very similar to the JSON idea. It's called key value pair. So if you think about what is JSON, usually we just have a lot of what we call key and the value pair. And key usually represent as a string, where value could be essentially anything. So that's we have been dealing with pretty much for the whole quarter. So we're going to actually look at the key value pair, and then we define a standard template library called map. Let's first take a look how you actually declare a map. So the map, of course, you need to include map. Okay, you need to include that. That is the one. And then again, we're going to try to identify where you're going to use, where is the standard template library. You see that this is STD, and something is called map. And then you have this template introducer. Okay, so this part is the declaration of map template. So in this map, I essentially saying that, okay, I'm declaring the first one should always be a string. A map should always be a string. And the second one is what is the value of that. So the value could be, in this case, the value of this map is actually always integer. So the difference between vector and the map is that the vector is an array. So you have an array of integer, but you use what we call index to actually go in to actually check whether this is a first element of the array, whether this is a second element of array. But in map, we're actually looking at another sometime usually is related to the meaning or the content of that particular integer. So essentially, I can do something. For example, here I have a map which shows the homework assignment for ecs36b, and it's how many points that, I mean, by the way, don't look at this literally, I just fake it, okay? So saying that, well, for this particular homework, how much you got from that, each of the elements. So essentially key value pair, instead of saying 0, 1, 2, 3, 4, 5, 6, 7, is basically homework 1 as a string, and what's the value associated with that. All right, so you can see that over here, I declare a map called n, and inside the n, I actually can initialize the value. So I initialize value, you can see that the initialization, this is what we call curly, this is called bracket initialization. In the bracket initialization, I have 3 element, which is homework 0 as a string, 10, homework 2, 15, homework 3, 20, because this is following the map, which is a string integer. Okay, so this basically give you some kind of initial element for the map. All right, so one question I want to ask you is that, does this remind you of anything? Does this part of the representation, does this remind you something we just talked about like 1 minute ago or 2 minutes ago? What's that? That's, yeah, well, it's not just, it's actually pairs. It's pair. So you can see that it's actually 3 pair, right? It's the string and an integer. That's what? That's a pair. We just look. By the way, the STD template, they actually using each other. So STD map is built on top of STD pair. So just show you the source code. I actually include the source code in the same GitHub. So I just want you to take a look at this. If you look at this file I gave you, if you search for class map, if you look at the class map, the value of a map, each of the element is what? Is a type defined. Is a type defined of a key and the TP. And the TP is essentially the type name of the second one, which you give. So essentially, a map is actually built on top of a pair. Okay, so if you know map is built on top of pair, what did you learn about pair just now? I just want to check in, make sure you follow with me. Well, what did you learn from pair? When you use pair, what kind of things did you worry about? What kind of thing you don't know about pair that you learned today? You learn anything? Yes. First and second, yes. So in math, you will see a lot of first and second. We'll see that. So whenever you see first and second, you actually see that because we're going to use map, we're going to use first and second. And then we're going to have that. Okay, so let's actually go back to the example of a map. So let me first tell you what did I do with a print map. So look at what I did with a print map. A print map is essentially go through a map and print every single element of that map. And so I have an array. I will actually tell you more about this a bit later, but essentially this is an iterator. An iterator, essentially, I got things out of a data structure such as map. So n colon m is a notation saying that n is a iterator. Whenever n is an iterator, then I just say n dot first and n dot second. That makes sense? Because why is that? Because map consists of a lot of pairs. And what I have is now I'm actually going through each of the pair in the element in the map. And therefore, I'm actually going to use first and second to actually bring it down. Okay, so that's essentially why how to use map in this case. Okay, let's actually first run the program, and then we'll go back for the rest of the example. Okay, so I'm going to do dot map. Let me do this. So I'm going to run the, oh, wait a minute, where I am? Map test, not test map. Okay, so let's actually take a look at the first line it does. The first line, it actually do init map, and then it basically print 3 maps. Let's take a look at the print map first. What is print map is really doing? Print map is print for each of the pair in the map. I'm actually going to print the first equal sign, second, and then I put a semicolon. That's why you have this after you did the initial map. You say HW homework 0 is 10 point, homework 2 is 15 point, homework 3 is 20 point. That's actually how you get that far. Okay. Any question? Okay, so let's take a look at the rest of the code to see, well, how do you actually manipulate the rest of the map? So when you did map, it's pretty much very like you do JSON. It's essentially you have a map. You can just using a operator overloading of that bracket and just directly access the string and then assign 25. So essentially what you're doing in this line, homework 0, take a look at this. Initially, homework 0 is 10 point. But after you did this assignment, homework 0 is 25, homework 4 is 30. The new map looks like this. Compare between this line and this line. Compare this 2 lines. Let me just highlight it here. You can see that what I did is this 2 line, I basically replaced the existing value, and I also introduced a new value. So essentially, whenever I use a map, pretty much just like a JSON, and then I include a particular key over here, if the key already exists, I replace the value of the old value. If the key doesn't exist, then I insert a new element over there. So that's what they're doing. So this is the way to add an element or to modify the value of an existing element. This is kind of really nice because you can see that in the programming, if you don't have a map, if you use a vector or an array, you actually have to write a loop. A loop have to go through every element to decide which element I need to find out is homework 0 or homework 4. So therefore, using map is really convenient if the label or the key is something which is you want to manipulate. Okay. So that's actually the value number 2. And the thing is that there was a case. What happened if I do this? Let me highlight this line. This line is kind of interesting. I try to print. You can see this line, I try to do std cout. I try to print the value of n, a string which is homework 7. If I do this, what do you think this will happen? Don't look at the top window. If I do this, what's going to happen? If you actually try to access to an element, it doesn't exist. So essentially, yes. Yeah. So unfortunately, C++, the map library, it won't. It actually took care of that for you. So map, when you try to access the element, I mean, the C, when we do C, we know it will crash. But this is nice thing about map. It won't crash. Whenever you try to access a key in map, I don't have it. So I actually, good point. I should take a look at the implementation of map. It might actually raise an exception, a catch, and do something. The way it works, this is important, is that if you introduce an element, you didn't assign the value, just try to read it, it will create an element and then assign the value of whatever default value. If it's integer, it's going to be 0. If it's whatever pointer, it's going to be null pointer. Okay, so take a look at this line. So if you take a look at this line, I didn't do anything. I just tried to print the content of a particular element of map doesn't exist. And the map will actually reactively create a element, which is that. So after this, you can see that after I create this one, after that, I actually update the map. Take a look what happened is that homework 7 is actually 0. So the difference between this one and this one was that particular line. I actually didn't do any kind of assignment like what I did with homework 4, and I just say homework 7 looks like this, and then you dump a map, is actually do that. Okay. All right, any question? All right, let's actually see how do you actually remove. So we talk about how do you add. I mean, even you don't intend to add, it will automatically add it to you like homework 7. So I want to tell you a little bit about how do you actually remove something. So what I did remove is you can just say m.erase. Okay, you can just say the map using the member function called erase, and given the key homework 2. After you've done this, you take a look at the result on the top. You can see that after you've done erase number 2, you see that homework 2 is gone. Okay. And also the rest of the thing is pretty straightforward. Other member function for each of the map, you can actually do M size. M size means how many elements you have that in the map. All right. And then at the end that you have something called M clear, which you can basically just erase everything. Okay. All right. That's basically the most important things about map. All right. Any question about map? Yeah.
So when they're creating new pair, we are having to do them. How do we differentiate between 2 or 1 and 3? Let's say how do we transfer over?
Okay. Number 1, the element in the map, they do not have a particular order. So you want to insert homework 1 and homework 2, you can actually insert a string called homework 1.5. Or you can say insert something called in the string, say between homework 1 and homework 2. So basically it doesn't have an order like an array index, but it actually will do the what do you call that? It will actually allow you to whatever key you specify. However, now I'm actually going back to the earlier things I show you. So when you do this, by the way, this is an important function for you to actually go over every single element in the map. and then you try to just display all of that. However, there is a one thing I want to ask you is that let me ask you a question. How do you actually do this? I want to search for my homework. I forgot which homework it is. It could be homework 3, 4, or 5. I don't know. But I want to search for a homework that's after homework 2. What do you do? So I don't know whether I have a homework 3 or homework 4, or homework 5. Maybe I have all of them, but I might not have. But I only know I have homework 2, but I know I have something after homework 2 I want to search for. It's just like a dictionary, right? So you want to say, hey, this word is called polymorphic. It is an English word. And I know there's a word that's alphabetically after polymorphic, but it's not polymorphic. I want to know whether that word ever exists in a map called dictionary. Then how do you actually do that? Think about this. Let me actually type it up so you can know what I'm saying. Is assuming I have a dictionary map. What is a dictionary map? Dictionary map is typically STD map. The first one is actually going to be STD string. That's the key. And the entry for that STD is going to be JSON value. And that's the type. I'm going to do this. I call it my dictionary. Okay, I declare a dictionary and somehow I load all the dictionary into this map called my dictionary. So now your job is try to find the entry right after the word or the entry polymorphic. Assuming polymorphic is all lowercase, okay? So how do we do that? Yes.
I believe map is ordered alphabetically is by the key. So then you could do a binary search on polymorphic. It'll return the one position right next to the nearest key next to what polymorphic would be.
Okay.
It had like,
Close enough. Okay. Yes.
it had like one size after like the iterated or
Okay. Okay. So you basically try to search for everything. Go through the size and just try to use it as an array, right? It's a bit inefficient, right? The iterator in map doesn't actually really give you an index. Doesn't really give you an index. So you're close enough, but let me actually show you that this is the way we do it. I actually give an example here. I actually comment out this code, comment out this 3 element. So map actually give you a function called lower bound or upper bound. So lower bound, basically you give a key, it will actually provide the first entry right after this key. Or if you have any element, either match exactly like this key, or is actually the key after that. So you can actually do that. So if you do m.lower bound, it will actually give you an entry of that if it actually exists. But if it doesn't exist, it will actually give you the next entry. Okay, so essentially, if in the case of polymorphic, we can actually use this to see, hey, if polymorphic exists in my entry, great, I can have it. And then you can use, I forgot the other function, which is, I should actually pull it out. Sorry about that. Where is my map? I actually dig out, not this one, not iterator. Yeah, here is a map. So So the map has an iterator, like what you said, is a begin and end. I'm sorry, I took it back. You can actually do begin and end, and then do a loop like this. And then you can actually do, you can do lower bound or upper bound, which is lower bound and upper bound is actually give you the key. That's actually what you specify, or is actually after that. That's the lower bound. And so lower bound will actually help you to get to that point. And then from there, you try to get to the next one. Okay, so that is what you can do. So in this case, let's actually look at this example. So take a look at this. I actually use an iterator. And how do I design the iterator for map is that I actually provide the map declaration, which is the string and integer. And then I declare colon iterator. This means IT, which is the variable, become the iterator for a map. And then I do an m dot lower bound. When I do m dot lower bound, is actually return the iterator. And that iterator, guess what it is? That iterator is a pointer to a pair. That's why I actually do IT to the first and IT to the second. So essentially the iterator is actually a pair, a pointer to a pair. Okay, so if you take a look at this code, let's just try to compile. Sorry. Yes, I killed it. So I just, So now you can see that I actually put this to HW2 is the first and 15 is the second. So IT to the first, IT to the second, so I can actually play around with that. Okay. Okay, so that's my quick introduction to pair and map. Any question? Okay, so now we're going to look at a little bit more complicated example about using pair and map to do something. Okay. So I actually write a program I call ecs36b value test.cpp. Okay, this is a program. I'm going to first show you what it is, and then you can actually tell me what this program looks like. Okay, so this program is already given to you. First, I actually have a type define and std map. So the way I do it is that I define a new type called object value. Can someone tell me what is object value as a data type? I define this new data type for object value. Can someone look at the code and tell me what that type is? Yes. Yes, it's a map, right? It's a map, and the instantiation is the key is a string, and the value is JSON value. And if you remember JSON value, what is exactly a JSON value? Can someone tell me very briefly what is a JSON value? Okay, the simplest answer to JSON value is that it could be anything. JSON value could be anything. It could be an object type. It could be an array. Can the JSON value be an integer? Yes, it can be an integer. So essentially, JSON value could be anything. If you remember what is a JSON value, take a look at this. If I go to JSON CPP, JSON value, sorry, I want to do JSON value. It's really, really useful data structure. That's why we use JSON value a lot. And remember this function, this part, the JSON value has all this functions, say, is null, is bool, is int, is unsigned int, is integral, is double, is numeric string, is array, is object, is converted to, which means that a JSON value could be any of those. It could be a null, it could be integer, it could be double, it could be string, and it could be object, it could be array. So essentially, JSON value from a C++ programmer perspective is essentially a generic data structure. I can map anything I want. Okay, so that's why in this data structure, I define a map. So the previous example, the map is a map for an integer or a map for a character, but now the pair, by the way, this is using map, and that map is actually a pair. The pair is going to be a JSON value, the second one. So it basically integrate a string pairing with a JSON value, which JSON value could be anything, right? Okay, so that's the object value. Okay, now I'm actually going to show you this piece of code. Actually going to show you this piece of code. So this is very simple. I do not even have a constructor or destructor. Okay, I only have one member function, which is the operator overloading. And then I have a one public attribute, which is the type object value, which is a map I call attr map. Okay, take a look at this code. What does this code is reminds you about this? There are really two lines, okay? So this line is actually fairly simple, right? This line, we already do that. We know it's a map. It's a generic map, which is the JSON value. But this map is actually a operator overloading. So can someone remember we talked about operator loading in chapter 12? Can someone remind us about what is that operator loading is doing? Yeah. Okay, so we're using that, right? We're actually defining a bracket, right? So what's the property about that bracket? So when you have a bracket, what kind of things you should worry about? When you see a pair of brackets as an array, what kind of things you should worry about? Let me just use this as an example. If I define something, I call it int ABC 200, right? So I do a int ABC is an array. And the thing is that, and that is an array. And what are the things you need to worry about when you use this array? What kind of things you need to worry about? Yes.
Does the value exist or is it out of bounds?
Okay, so I will thank you. That's important. But the thing is that is the index, right? The index part of the array. So you're talking about whether the array is the value is out of the range, right? But I think the question I asked was a little bit vague, so I have to clarify. So when we look at the array, we actually look at two things. One is what is the data type of the element, whether it's an integer array or is a struct array. That's number one. Number two, I want to know what is the index, the data type of the index. So pretty much the array that you learned so far, at least from ecs36b, is the index by default is actually an integer, right? That's what you have learned. But now when we actually declare the overloading, we actually can allow us to have a index that might not be an integer. Just like in the map, we actually allow a string to be the key, to be a different kind of index for us to be able to search. By the way, what's the tool you have been using is using a string as an index. If I say index engine, which company reminds you? That company is started with a G. Google. I mean, essentially Google, the core of the Google search engine is called index engine. Why is index engine? You actually provide the keywords and it very quickly go into that huge hash table and try to find out which entry is the most likely that correspond to that particular index, which is the keywords that you provide. Okay, so index is essentially you enter a few keywords, and I actually give you something which is the higher rank related to that keyword. Okay, so the thing is that whenever we talk about an array, there's always two things. Number one is what is the data type of the element I try to index into. But the second issue is that what should be the data type of the index itself. Okay, so now I'm going to ask you this two questions. What is data type of the element? What is the data type of the index? So by take a look at this, the way declare, can somebody tell me what is the data type of that element in this map? Yeah. It's a JSON value. Okay, it's a JSON value. And what should be the index itself? It's a string, right? It's a string. So that's why when you saw this, you actually see a lot of things together. The return value of a bracket overloading operator is actually a JSON value, which means it can be anything. Okay. By the way, when you take a look at the JSON value, don't think about it as a JSON as a curly bracket. An integer is a JSON, by the way. Okay. Everything is a JSON. That's the generic way to do that. And then inside the bracket, we're saying that, hey, I want to have a character star. Okay. So, okay, by having this, now I'm actually by a very simple class. A very simple class with, if I don't give you this line about overloading, it's just a map, right? It's just a map. But now I'm actually give you an overloading. What does this remind you? Oh, this is actually a very vague question. Let me tell you how I, yeah.
And JSON value, that operator is also overloaded in the same, I think in the same kind of way, right? Access using a string.
Yeah, Nicholas, you're right. Your instinct is right. Let me tell you that how I got this piece of code. I actually dig out the full implementation of JSON value. I look at the JSON value source code, and I start to get rid of things that's irrelevant. And eventually, this is the line I have left. Okay, let me actually show you where that code is. Okay, let me tell you that the way it works. I thought I dig it out today. I'll do a Google search again. I use Google so much. JSON, CPP, not JSON CPP. I will say JSON value implementation. Source code. Okay, this should be the one. The source code, I will go to SRC. Inside SRC, I go to lib_JSON, and then I go to JSON value.cpp. Okay, so this is basically the code. And then I do let's do a class. I need to do a search. Sorry. What was it's called object values. Let's actually take a look at object value. Object value. No, it's not declared here. Sorry, it's in the include file. So I have to go back. Yeah, I looked sometime I just look for so many code, I forgot where I see this. JSON. And then I go to value.h. Yeah, this should be the place. That's not good. I thought it was here. 1 second. Here. Okay, so this is the way in the JSON object, what they declare. So they basically declare a type defined STB map, but they actually use a different kind of string called CZ string. CZ string is similar to STD string, but it has more operator that's actually they're using. But the thing is that you can actually just use an STD string instead of a CZ string. So they actually declare this as object value. And then they're basically using this to declare, where's the object value? See, all this function is just what I show you earlier. It should be around here. Today, what I did is I take this code and then just get rid of all the line I don't need. Let me actually do a search very quickly. Yeah, here. This is the line that actually left here is the map. Okay, so essentially those two lines I show you is essentially the line, the first line, I actually put it there, is just give you a map. And then the other function, which I have, is the operator. Operator bracket, which basically is give you all the operator, but one of them is actually a string operator that you can actually include that, okay? So now I want to go back to here. So now you kind of have some idea about this is essentially a simplified version about a very complicated data structure called operator equal equal. But essentially the core of the whole implementation is just a map. It's just a map and a bunch of functions that including operator overloading. You think about that, the rest of that is just bool, is null, is a string. It's essentially just compare the first and second of each of the element in the attribute map, which I actually call the ATTR map, but in their implementation, they just do an underscore map. Looks like this. Okay, so now I can take a look how I actually implement that operator map. So first, take a look at how I actually implement the operator overloading. This is the real code. So essentially, I do an iterator. See, I do an iterator again. Just like the way I show you when I show the map, I have the iterator, I have the lower bound of the key. Basically, that's supposed to give me the iterator, which is what? Which is actually a first and a second. Because of what? Because it is a pair, okay, in that case. So anytime you see first and second, you know that it's a pair. So this code basically say the first part is saying that, well, if you actually don't have the key is not available. Why I know? Because the iterator is not equal to the end. It means that you already go to the end and it's still not equal to the key. Then, sorry, this is if the key exists, then you actually return the second. But if the key doesn't exist, you actually initialize the value null. Okay, so now you have a new key. You initialize a null, you return a reference. Okay, you return the reference as this. You kind of insert it, and then you return. So let me actually show you the code. How do you use this? So take a look at this 2 lines of code. Is a fascinating way of you doing operator overloading on the bracket. The first one is actually an assignment. So I have that bracket called my value. And what it does is that I find out the key. I found it, the entry, and what should be the return of this part? The return of this part is a reference to a JSON object, and then I assign the value to be 1, 2, 3. So after this line, whatever the attribute value should be assigned to the value. Well, the thing is that if this value doesn't exist, it will return a null object like this. But if it already exists, it will just return the second. So basically, let me actually show you what happened. That this is the case. The key exists. And this is the case. The key doesn't exist yet. Okay, so this is a 2 case. So that's how those 2 function that this part, if you look at the code over here, this one actually return because you never have the key 1. Key 1 is a new one, so it doesn't exist. So this one return a reference. So you can assign 1, 2, 3. And the second one is already exists. So just print out the value 1, 2, 3. But let me give you an example. Give me 1 minute. I want to show you this program to see what happened. Let me try to make it. And I'm going to run ecs36b value test. You can see that it actually printed out 1, 2, 3. But now I'm actually going to make a very simple change. I'm actually going to change this operator overloading to without the n. So I get rid of the reference. So I have to get rid of this reference as well. If I get rid of the reference, let's see the result. It's null. You no longer get 1, 2, 3. Let me actually show you the code again. If I actually only return not the reference, but return the value, why this one is actually give you a null. The reason is that it's actually not give you the reference for that original map. It's just give you a copy of the map without reference. So when you assign the 1, 2, 3, you're not really assigned to the ecs36 value. You just assign to a copy of that value. It's not called by reference, it's called by value. So therefore, when you try to print this one, it's null. Why is null? Because it was the default value. I actually assigned it to be null. Okay, that's the implementation line by line with the JSON value. Okay, all right. So I will see you on Wednesday.